Okay, so welcome everyone to Math 128. Hopefully everyone is good. So here's the plan for today and this week. So today we're going to take up the first assignment, and then tomorrow I think we'll just do something from the next chapter, unless people specifically request a review. And then on Friday is the test. And we'll just do that online. I'll just email it to everyone in the beginning of class. And then you just submit it within like an hour and 10 minutes. I give a little extra time in case anyone has any technical issues. And Sasha, in regard to this stuff, just send me an email and we'll discuss it. And try not to worry too much about it, because we'll figure it out and we'll get you caught up.
Okay, thank you.
You're welcome. What else? Okay, so in regard to today, I think originally I was just going to present the assignment, but I think I might also post the solutions as well. I haven't really decided, but I do have the solution set, so I might as well just post it. So here's what we'll do. I'll post the solution set after class, and then I'll go through whatever anyone wants to go through during this class. I have a feeling most people are probably, like, we already did a full review last time, and then this whole thing is kind of the same. So yeah, anyone who wants to head out and continue on with their day is free to do so. Otherwise, we'll go through it, and I'll try to go through like the most difficult questions. And let me just double check the attendance in case anyone decides to head out early. Where's the attendance? Here it is. Okay. We almost have everyone. When will our assignments be marked? Very good question. They'll at least be up before the test. I'll try to get them up like by tomorrow. Who else is here? Do we have both Haley's? Haley, we got one. What else? Holly. Julia, got that person, and yep, almost everyone. Okay, so someone said, how many questions for the exam? There are no technical exams in this course. I'm assuming you're just referring to the first test. I think there's about 12 or 13, and it pretty much just looks like the same assignment. Yeah, someone just asked me about what how many questions on the test. So yeah, it's the same as the assignment pretty much. Okay, so let's, what else? Let me see. So let's start. So I have everyone marked down with the attendance, and like I said, you're free to stay, you're free to stick around. So let's share screen. And
so for the test, if it's like the assignment, are we supposed to like print it out and then write on that and then send it in?
Well, when I say it's like the assignment, it'll have like similar questions and stuff. Like it covers adding fractions and subtracting fractions and all the usual stuff that we go through.
Yeah, but like, are we supposed to like?
Oh, I'll send you an actual version of the test in the beginning of class.
Yeah, and then how do we show it on the computer?
Oh, okay. Yeah, good question. Sorry, I misinterpreted your question. Yeah, so if you have a printer, you can print it off and fill it out and take a picture of it and scan it and submit it that way. If you don't have a printer, worst comes to worst, just do your answers just on a piece of paper, take a picture of it and submit it on Dropbox.
Okay, thank you.
You're welcome. Okay. So I think we should go through. First, let's take some requests. So for the assignment, is there anything that any specific topic anyone wants to go over? I just figured I'd ask before I choose one. I haven't marked them yet, so I guess that's a bit of I'm not going to get very many answers. Okay, so let's do what everyone usually has the most difficulty with, which is adding fractions. Let's do a couple of those, and then we'll see what else anyone feels like doing. Okay, so adding fractions. Which one should we do? Okay, so let's just do the first one, 2 over 3 plus 3 over 10. Okay, so when we add fractions, we have to make sure that we eventually get the same bottom number on both of them, or on all three of them, or however many fractions there are. And this, we've done this process a bunch of times. It's called finding a least common denominator. So the first step is finding a number that's a multiple of 3 and a multiple of 10 that works for both of them and is the least number. So in this case, what would be the LCD, the least common denominator? Someone said, yep, it would be 30, exactly. Very good. So in this case, least common denominator is 30. And now let's change each of these fractions. So you just look at each bottom number and you ask yourself, what do I need to multiply this by to get to 30? So times 10 in this case, and then whatever you do to the top, you always do, or top, you always do to the bottom, and vice versa. So you have to multiply both of them by 10. And then times this by 3, this by 3. And now you get, first one is 20 over 30. I suppose for the first one, you could have just added a 0 to the end of each of them. That would have been an easy way of doing it too. And then the next one will be 9 over 30. So then we got 29 over 30. And yep, so that's what we do for those. So there's a bunch of other ones. I'm not going to go, I think we probably wouldn't have time for a ton of them either. But let's do one of the subtraction ones. And as I noted before, for some reason, people have an easier time with subtracting fractions rather than adding them. And yeah, I don't know why, but be sure to practice both, right, buddy? Where's my cursor? Here it is. This one was 9 over 10 minus 3 over 5. So in this case, what would be our least, oh, we got another, someone's very quick. We got, someone said 10. Yes, for this one, 10 works. 10 is the best thing, definitely, because it's, of course, the smallest number that works, and there's already a 10 there, so that's really easy. So you don't have to rewrite that one. So we only have to, so let's just write LCD equals 10. And we just have to rewrite the second fraction. The first fraction already has a 10 on the bottom. So multiply by 2, multiply by 2, and you get 9 over 10 minus 10 over 15. And then you get, is that, no, sorry, 6 over 10, sorry, geez. I must still be tired. Okay, so this will be 3 over 10. So that's what you do for subtraction. It's virtually the same thing as addition. You just subtract the numbers on top rather than adding them. There's so many fruit flies in my apartment, it's distracting me. Go away. Let's do the last one, because this one actually has three fractions. Sorry, I keep stuttering, especially when I'm tired. Apologies. And it also has a plus and a minus part. So let's get rid of this. Okay, so this was 1 over 3. Geez, I didn't realize how many of these. Okay, I guess, yeah, only 2 of them have a common denominator of 30. I thought there were more. So it's 1 over 3 plus 3 over 10 minus 9 over 15. So for this one, I would use my my method, which is where I just look at the largest number on the bottom. I test to see if that works first, and then I start going through multiples of the first number, and I just pick the first one that works. So for example, 15, let's try that. 15 does not work. It's not divisible by 10. 30. 30 works for both of them. Yay. Ugh. Okay, 30, good. Okay, so let's change the first one. We want to multiply it by 10 on the bottom. And just to remind everyone, I think one of the most common questions is where do you keep pulling these numbers from? And again, you just want to get 30 on the bottom, and you're looking at each bottom number, and you're just trying to figure out how to get to 30 using multiplication. It's always using multiplication. Oh, and then I have to clarify something, but let me finish this first. Okay, so times 3 times 3 times 2 times 2. So we get 10 over 30 plus 9 over 30 minus 18 over 30. And a lot of people don't know what to do in this case because there's a plus and a minus sign. Now, in general, and this is referring to BEDMAS, between addition and subtraction, it doesn't make a difference. So you just do it from left to right. And that was the rule that they came up with. So just from left to right. So just do the first one. First one is 19 over 30, if you add them up. And then you do the next one. You could do it all in one step, but this is just for illustration. And you end up getting 1 over 30. We got some comments, 1 over 30, yep, exactly. Oh, I saw a mistake in, what was I marking? I think I was probably marking another class because I haven't marked these assignments yet, but it still applies to this class. So I saw a mistake. It's not super common, but it's like a really bad mistake, and you got to be careful with it. Hold on. This is actually a perfect example for it. It could have been this example because I reused some of my questions, to be honest. Plus 3. Let me rewrite this example. So previously we did, what was it? Cancellation when we did multiplying fractions. You could also kind of use it with dividing fractions because with those you convert them into multiplication questions. So it kind of applies to both of them, but it does not apply to adding fractions or subtracting fractions. So you can't do it with that. Some people try to, and I understand the logic. It would make it a heck of a lot easier if you could do some cancellation before you add your fractions, but it just doesn't work. Like for example, doing this doesn't make any sense. You can't do it that way. It only works because multiplication has specific properties. Yeah, because when you're multiplying numbers, the order never matters. So if you have a 3 on top and a 3 on the bottom within a multiplication expression, it's just the equivalent of having 3 over 3 within that expression, which is the same as 1. And multiplying by 1 never matters. That's why you're allowed to cancel out stuff that's on the top and the bottom, but only when it comes to multiplication for those reasons, but never addition. So I just thought I'd clarify that. What else do we have? What else are something that people have trouble with? Any suggestions for anything anyone wants to cover? Don't be shy.
Clarifying, the times 3 and the times 2
Yes.
are because of I already did this question not even half an hour ago. I always forget where we get those from.
Okay, so let's look at this. So they always come from first the fact that we have to pick the least common denominator, right?
Yeah.
So in this case, we have 30 as our least common denominator. So now let's just look at each fraction separately. Here, I'll just write them like this. So for each question, you ask yourself, for the bottom number, what would I hypothetically multiply it by in order to get to 30? So 3 times what gives us 30?
Okay, gotcha.
So in this case, it would be times 10. And then of course you have to do it on the top as well. And
Yeah.
then you'd just go to the next one and ask yourself 10 times what number would give us 30. And then you just deduce that number.
Okay, gotcha.
Yeah. So
I always
that's why
forget. Like I know the formula, which means like I know how to do it, but I'm always like, where the heck am I getting these numbers from?
Yeah, it's an understandable question. Yeah. So everyone just always keep in mind that they're pretty much deduced from the least common denominator and just from, just deducing it from basic multiplication.
Thank you.
You're welcome. What else do we have? Any other questions about anything in general? I'm happy to answer anything. What about you, buddy? No questions? Okay, let's do a few more things. I don't want to end too early. I'm just trying to think of what I think people will have trouble with. Okay, I'm just going to go through these one at a time. People are usually pretty good with the multiplication, typically, and then the division questions are kind of hit or miss. The people who remember how to do them really well. The people who forget how to do them always just do 0 on them, or get 0 on them. So let's do one of those. And for this question, all you have to remember is, and I guess the assignment or the test on Friday, I mean, it's technically open book and open computer, so I guess you don't really have to memorize that much, but yeah, so 1/5 divided by 7/15. So does anyone remember what we do with this question? It's pretty easy to summarize the solution, or at least summarize the method.
Flip the second fraction.
And
Multiply.
yes, exactly. Perfect. So you flip the second fraction. First one stays the same. And then you change the sign to multiplication. So yeah, when you're dividing fractions, you don't have to do anything super complicated. Don't do long division. Yeah, even I don't know long division. I teach it like once every 2 years, and I forget about it once every 2 years. So yeah, in this case, flip the second fraction, change to multiplication, and then just treat it as a standard multiplication question. Multiply the top numbers, you get 15. Multiply the bottom, you get 35. And 15/35 does reduce to a lowest term. And I guess I can give a bit of a summary on reducing the lowest terms. So for reducing the lowest terms, it's where you look at the top number and you look at the bottom number and you ask yourself, what would divide evenly into both those numbers? Or how else can I phrase it? Is there a factor that is common to the top and the bottom? Like, for example, looking at 15 and 35, right away, you know, they're both divisible by 5. They both have 5 as a factor, because anything ending with 5 or 0 has 5 as a factor. So at least 5 will work. And in this case, I think that's all you can do is just use 5. So you divide by 5, and you get 3/7. And 3/7 does not reduce. So that was multiplication and reducing. And for the test, please reduce all of your answers to lowest terms, and that will be specified in the instructions as well. Okay, so that was, what else do we have? So we did the adding and subtracting. What about, oh yeah, let's do, oh, hold on. Let's do converting from fractions to decimals, because I think you could argue that this is the easiest question that we deal with, but for some reason, everyone always just forgets about it, just always. And I think that's probably because it's pretty easy and people just don't bother retaining it in their brains. So converting from decimals to fractions. Does anyone remember the method for this one? Let's say 0.801. Let's do that. Anyone at all? Oh, we got a chat. So someone said 801/1000. So yes. So how do we get that answer? So it's always the same for these ones. You just count how many decimal places you have. In this case, you got 1, 2, 3. So at the bottom number, you'll use 1 with 3 zeros. In other words, it goes to the quote thousandths. So you put 1,000 on the bottom for the bottom number. And then for the top, you just use the actual digits. You use 801, and that's what you do for these ones. So make sure that when you write it on the top, you don't write the original number. you have to just write the digits. The dividing by 1000 part already takes care of everything else. So you don't need the top part to be an actual decimal number. And that is how you do these in general. Just count how many places you have and then use that on the bottom, and it's always a multiple of 10. So this one is 1, 2, 3, 4 places. So on the bottom, you got 1 with 4 zeros, and then 2 over 10,000. In this case, you don't have to reduce these ones because I don't see any point in reducing them. Let's see. Then we had rounding. Oh, and then we had, oh yeah, I forgot to do this during the actual review. Turn 9 over 10 into a mixed number. Someone said they blanked on that question. Okay, let's do that. 9 over 10 into mixed. So we got 9 over 10. Oh, let's see, another chat. Oh yeah, 9 over 2. Sorry, I'm tired, apologies. Okay, very good question. So this is turning improper fractions into mixed numbers. So what was the procedure for this one? And this one was the one that is a bit less algorithmic. Someone said 4.5, which is technically the right answer, but yeah, and then they just wrote something further, or yeah, someone clarified 4.5 is what you would end up getting. Yeah, for these ones, I wouldn't accept a decimal number because the point is to convert them to a mixed number. Oh, and sometimes people send me private messages. So if people are confused about what I'm talking about, that I'm responding to people's private messages, but I'll try my best to clarify what the person's asking. Okay, so let's look at the procedure for this one in general. What was the procedure? It was you look at this number right here and you ask yourself, how many times does it fit into 9? How many times would it go into 9? How many whole times without going over? So in this case, how many times would that be? So we got 2, we got 4, we got 6, we got 8, we got 10. If you went up to 10, it would be too much. So it goes in 4 times. So 4 is what you use for your mixed, or for the whole number part. So 4 is what you use for that. And then the last part is you count how many numbers are left over. So in this case, you were brought up to 8, so 1 number is left over. So you would use 1 as your numerator, and then you would put it over 2, because you always just use the same number for the denominator. Does anyone else have any other either mixed fraction questions or any other questions in general? Okay, let's do a quick, because I forgot to do this or we ran out of time during the review. Let's quickly go through percentages because there are always a lot of mistakes with those. So with percentages, you basically just convert like a percent to a decimal to a percent, a fraction to a percent, stuff like that. So it's all about converting. And really, the only thing you technically have to remember about percent is that it means per 100. It means out of 100. So with percentages, you're usually going to be doing something involving 100. And so that could be dividing by 100, multiplying by 100, or it could be moving the decimal over twice in either direction because it goes tens, hundreds. So multiplying something by, or moving a decimal over twice to the right means multiplying by 100, and then moving it to the left is the same as dividing by 100. So it's always involving 100 in some context. So this is, let's do 0.62, and let's convert it to a percentage. So you just move your decimal over twice in this case. It's always twice no matter what. And you just have to remember, does it go to the right or the left? In this case, it goes to the right because if you moved it to the left, it just wouldn't make any sense. Like this is 62 hundredths by definition. So it's 62 over 100. So it's going to be 62%. So, or you could just memorize it, and you could just memorize like, okay, from decimal to fraction, you move it to the right, and then you move to the left in the other direction. It's up to you how you want to look at it. It's pretty easy to remember. So take the decimal, move it once, move it twice, it gets right here, and you got 62%. So that's how you do from decimal to percent. and then going from percent to decimal is just the opposite. So for example, we had, let's do the 0.15% because people always get this one wrong. So like I said, move it over twice. So what should we do in this case? We should move it over twice. So once, and then twice. And here you go. So you get 0.0015, which people think is like a weird answer, but it's a perfectly fine answer. Like our original 0.15% is a really small number. Like it's almost 0%. So it makes sense that this number is going to be pretty close to 0. So yeah, this is like a particular question where they'll move it over once, or they'll move it over 3 times, or they'll move it in the opposite direction. I think it's because they're expecting a certain answer. But yeah, just move it twice and you'll be good to go. And then, oh yeah, and then there was converting from fractions to, converting from percentages to fractions, which is definitely the easiest one and pretty much only requires one example. So this one, you take away the percentage sign and then you put the number over 100. So you got 8 over 100. And that's all you have to do. So it's 2 steps: remove percentage sign and put it over 100. What are you doing, buddy? Hold on. What's buddy doing? Oh, hold on, we've got a chat. Sorry?
Sorry, can we do some of the percentages to fractions?
Yes.
I mean, sorry,
The fractions to percent?
no, which one? The one with like the whole number and then the fraction.
Whole number and then the fraction.
Like the big number and then the little one, the little fraction.
Sorry, yeah, I'm not sure which one we're referring
He
to.
wants to do mixed numbers.
Sorry,
Okay.
yeah, mixed numbers.
Oh,
Couldn't think of
okay,
the
okay.
name. Thank you.
Sure. Let's just quickly finish on the topic of percent, and then we'll go to mixed numbers. Yeah. So the 8 over 100. Okay, so there was that one, and then the last one possible is converting from fractions to percent. So let's do one of that, and then we'll go to the next topic. So let's do 1 over 8, converting it to a percent. So for this one, first thing you do is you just take your fraction and go in your calculator and do the top divided by the bottom and convert it to a decimal number. So in this case, it's 0.125. That's what this is as a decimal number. And then you just convert from a decimal to a percent. So then you move the decimal twice to the right and add a percentage sign. So once, twice, and you get 12.5%. Someone said 125%. No, in this case, it would only be 12.5%, because 125% would mean that the original number was greater than 1, but the original number is only 1 over 8. It's nowhere close to 1. That's okay, no worries. Yeah, in that case, you moved the decimal 1 too many times. It should have just been just right there. So there are a lot of mistakes that everyone makes with this. You have to, like, a lot of people will just get the answer as 0.125, and then they'll stop at that point, and they'll totally forget the question was, like, it was asking them to go 2%. So they didn't really answer the question. So you have to remember to keep going to the last step. Another thing that people do is they'll change it to a decimal, but then they won't properly convert it to a percent. So if you slap a decimal sign on it, you do have to make sure the decimal is moved over. So if you just slap a decimal sign here and claim that that's the answer, it's not the answer. You have to move the decimal over twice when you're converting it to a percent. So just be careful. So there's like 3 or 4 little mistakes in this one that everyone makes. And then another one that everyone makes is like for 6 over 5. 6 divided by 5 is 1.2. And then a lot of people will just claim that the answer is 1.2%. And it's not. Even just on the surface, it's not. Because like let's say you got 6 out of 5 on a test. You should be really happy about that. Like you got more than 100% on your test. So if your teacher claimed that you got 1.2%, you would tell the teacher, your math is a bit off. I did really good on that test. I got more than 100 on that test. I didn't get like around 1% on that test. So this answer, from a practical point of view, doesn't make sense. So the answer as a decimal is 1.2, but then you got to remember, move it over once, move it over twice, and you get 120% for that one, which would make more sense if you put it in the context of writing a test. So in that case, you've done really well on your test. So let's go to converting from,
By 100.
sorry?
Just multiply it by 100.
Yep. Or are you asking why?
No, I was just trying to help.
Okay. Yeah, and everyone keep in mind it's always 100 because 100 is always associated with percent. So let's go to the mixed numbers. So let's see. Was there any particular question you wanted to look at? So did you want to look at, are we going from mixed to regular or regular to mixed? Let's do both. Okay, so let's do the first one, 2/5, and converting it to just a regular, I just call it a regular fraction. It's technically an improper fraction. Let's do this one. So this is the one that is a little bit more algorithmic. It pretty much has a formula. So what you do is you take your 2, you multiply it by your 5, and then you add your 1. And that's what you get for, that'll give you the top number of your fraction. So that's 2 times 5 plus 1. And then for the bottom number, it always just stays the same. It'll just stay as 5. So for this one, you get, so 2 times 10, or 2 times 5 is 10, plus 1 is 11. So you get 11/5 for that one, which seems reasonable. Yeah, if you like, there's a 5 in there, there's another 5 in there, there's 1 left over. So it actually makes sense that as a mixed number, it's 2 and 1/5. So now let's do, let's do 1 in the opposite direction. Okay, so in the opposite direction is converting from an improper fraction to a mixed number. So let's do 15/4, convert that to a mixed number. So this is a bit less algorithmic. It's a little more difficult. So this is the one where you count how many times does the bottom number go into the top number? How many whole times does it go in? In this case, 4, 8, 12, and if you went up to 16, you would go too far. So it only goes up to 12. It goes in 3 times. So you got 3 for your whole number. And then you count how many are left over. So you went up to 12, and that includes 12. And then you just count, okay, so 13, 14, 15, and you got 3 left over. So you got 3 and 3/4. And of course, in this case, the bottom number always stays the same as the original question. Oh, did someone say, someone said 2/4. No, in this case, it would be, yeah, it would be 3/4 because you got 13, 14, and 15. It includes the 15. Does anyone have any other topics that they want to cover? Oh yeah, and we do have a class tomorrow, I guess. If anyone has any questions tomorrow, we can go through them tomorrow as well. Otherwise, I think we'll just start on something new. Okay, so I'm just going to stop the sharing. Here, I'll let everyone see Buddy for another minute. He's been here just sitting like that the entire time. So yeah, if you want a pet, get a bearded dragon. If you want one that you could just hang out with all day long, they're so cool. Okay, any final questions? Okay, so everyone seems pretty good. Awesome. So everyone, thank you for coming. and I will virtually see you tomorrow. Oh, can I stay for a minute? Sure. Sure, I'll mute it for a second and I'll pause the recording and everyone can head out. And then if anyone has any questions, I'll be here. Have a good day, everyone.
Thank you.